Let's do a practice problem. Construct a 95% confidence interval estimation for the population proportion of blue M&Ms based on a sample of 50 M&Ms that contains 14 blue M&Ms. So please pause, work on this problem, and come back to see the solution. This is the formula, by the way, for a 1 minus alpha percent confidence interval for P. That's point estimate P hat plus minus Z of alpha over 2 multiplied by P hat 1 minus P hat over N. All right, let's see the solution. So first we need to compute P hat. P hat is X over N. X is the number of blue M&Ms in the sample. We have a sample of 50 items, so that would be 14 divided by 15, which is 0.28. Now that we have P hat, we can plug it in this formula, the confidence interval formula for P. So P hat is 0.28, 0.28 plus Z of alpha over 2, the critical value for alpha equal to 5% here, because we are looking for 1 minus alpha percent confidence interval. When 1 minus alpha is 95%, that means alpha is 5%. So we are looking for Z of alpha over 2. That means Z of 0.025. Z of 0.025 is 1.96. You can find this from the Z table, or you might actually remember it from our confidence interval examples that we had for the average mu. And then the standard error. So this is P hat, 1 minus P hat over N. And when we do that, we can compute the interval. So the plus is going to give us, this plus is going to give us the upper level, and the minus is going to give us the lower limit. So this is a confidence interval for P. You would say we don't really know what the proportion of blue M&M in the population of all M&Ms is, but we are 95% confidence that it's a value between these two, 0.16 and 0.40. So 60% and 40%. And this is our estimation for the population proportion of blue M&Ms. So we provided a range and also a confidence level. Next practice problem. Suppose N, the size of the sample is 200, X is 50, that's the number of items or individuals of interest. We want to construct a 95% confidence interval estimation for the population proportion, and you have the formula down below. So please pause, work on this problem, and build a 95% confidence interval for P, and then come back to see the solution. All right, so let's see the solution. So the first thing that we need to do, we need to compute P hat. And P hat is equal to X divided by N. X here is 50 and N is 200. So P hat here is 0.25. Then we plug it in this formula. Z of alpha over 2 for 95% is again 1.96. And we compute also this value, the standard error, and that would give us the confidence interval, which is this interval right here. So we would say that we don't know what P is, but we are 95% confidence that it's a value between 0.19 and 0.31. Next practice problem. If N is 400, the sample size, and X, the number of items or individual of interest, is 25, construct a 99% confidence interval estimation for the population proportion. So you have the formula here. So please pause, work on this problem, and then come back to see the solution. All right, so let's see the solution. So first we need to find p hat. P hat is x divided by n, so that would be 25 divided by 400, and that's equal to 0.0625. So that's p hat. Next, we need to find the critical value z of alpha over 2 for 99%. So if 1 minus alpha is 0.99, 99%, this means that alpha is 1%, 0.01. You're looking for z of alpha over 2. So this means that z of 0.01 divided by 2, which is z of 0.005. So if you look at the z distribution table for 0.005, z of 0.005, you're going to find it as 2.576. So that's the critical value. And then we also find the standard error, and this would give us the confidence interval. So we would say that we don't know what p is, but we are 99% confidence that it is a value between 0.031 and 0.094. Next practice problem. A telephone company has the business objective of wanting to estimate the proportion of households that would purchase an additional telephone line if it were made available at substantially reduced installation costs. Data are collected from a random sample of 500 households. The results indicate that 135 of the households would purchase the additional telephone line at a reduced installation cost. Part A. Construct a 99% confidence interval for estimating the population proportion of households that would purchase the additional telephone line. So you have the formula down here. Please go ahead and compute the confidence interval. So let's see the solution for part A of the problem. So we want to build a 99% confidence interval for the proportion of people that would purchase the additional line. So based on the formula, we need to first find the p hat, the proportion of the sample. And that's equal to x divided by n, which is 135 divided by 500, which is 0.27. So p hat, the point estimate is 27%. So we're going to plug it in here, and then we need to find, we already have found the z of alpha over 2 for 99%, and that's 2.576. We also compute this value, the standard error, and that's here, and that would give us this confidence interval. So we would say we don't know the proportion of people who would really purchase the additional telephone line, but we are 99% confidence that it's a value between 0.22 and 0.32. Let's now solve the part B of the problem. What is the margin of error? So the margin of error is the critical value multiplied by the standard error. So please pause, work on the problem, and then come back to see the solution. All right, let's see the solution. So the margin of error is the critical value z of alpha over 2 multiplied by the standard error. In our problem, that's 2.576 multiplied by this value, which is 0.051. So the margin of error is about 5%. This is the half of the width of a confidence interval, from the point estimate either to the right or the upper level or to the lower level. Next part of the problem, part C. How would the manager in charge of the promotional program concerning residential customers use the results in part A? The results in part A was a 99% confidence interval for the proportion of customers that would purchase the additional line at a reduced cost. So think about this question, pause, and then come back to see the solution. All right, let's see the solution. So the confidence interval that we built is here, the 99% confidence interval. The proportion of customers who would purchase the additional line is something between 22% and 32%. So the manager of the promotional program should think about this number now that it has an estimation, a 99% confidence interval estimation, to see whether this is actually profitable based on their cost and based on the program, knowing the estimation of proportion. If it is, they should do it, otherwise they should not. This problem. A random check of 500 batteries manufactured by a company found 15 of them defective. Construct a 95% confidence interval for the proportion of all batteries manufactured by the company that are defective. So please pause, work on this problem and find a 95% confidence interval, and then come back to see the solution. All right, so let's see the solution. First, we need to find p hat, the proportion of batteries defective in the sample. That's 15 divided by 500, which is 3%. Then we're going to plug it in this formula. Z of alpha over 2, the critical value for 95% is 1.96, and then we compute the standard error, and we would get the confidence interval. So the 95% confidence interval for the proportion of batteries that are defective is something between 0.015 and 0.045. B of the question. A random check of 500 batteries manufactured by company found 15 defective. Part B. What is the margin of error for the 95% confidence interval for the proportion of batteries that are defective? So please pause, find the margin of error, and then come back to see the solution. All right, so let's see the solution. The margin of error is the critical value Z of alpha over 2 for 95% multiplied by the standard error, which is p hat 1 minus p hat over n. And for our confidence interval for 95% is equal to 0.015, which is half of the confidence interval width.